we are talking about heat curves. So this is the example that's found in your PowerPoint. We are just going to work through it, and I'm going to take you step by step so you understand how to do it. So it says, what is the total amount of heat in joules that must be added to 165 grams of ice, which is solid H2O, at negative 5 degrees Celsius to change it into steam at 103 degrees Celsius? Okay, so we're definitely going to need this formula. This is going to be our change in temperature, and you're going to use this every time you see your temperature changing. Okay, so our heat curve is going to be time is your x-axis, and temperature is going to be your y-axis. So anytime you see a change in the temperature, you're going to use this formula. So these dotted lines are going to represent different temperatures, but key temperatures. So this first one is going to be 0 degrees. Okay, so at 0 degrees, anything below it is going to be solid. So this is going to be ice. You're going to use this formula. This flat line basically is representing your melting point. This is the point where your ice is going to start becoming a liquid. So your temperature is going to stay consistent until it gets all the way over here and everything has been melted. Here, this is going to be called the heat, molar heat of fusion. Okay, so you might see it like that. And it is also provided up here. Oh, I forgot the H. You get the point. So here we have another temperature change. So here, everything is melted. We have liquid. Okay, you're going to be using this temperature again. You see we have another plateau, another flat line. So this is at the point where liquid is becoming gas. So this is going to be your boiling point. This point is also going to be known as the molar heat of vaporization. And then here, you're going from liquid to gas. So when your temperature starts changing, this is going to be gas. And again, you're going to use this formula. For these portions, you are going to use the information that's provided in your box for you. So let's walk step by step. I'm going to label this point number 1, and that's the first thing we're going to do. So we're solving for Q. So Q equals your mass is given to you in your problem. It's 165 times your specific heat. Specific heat of ice is given to you right here. It's 2.01 joules per gram Celsius times your change in temperature. So the temperature that we're starting with is negative 5 degrees Celsius. And then we're going to do it up until it gets to 0 degrees. So remember, change in temperature is going to be final minus initial temperature. Okay, so you do 0 minus negative 5. Okay, so remember when you do 0 minus negative 5, this is going to be plus 5. So I'm going to rewrite it. So 165 times this is grams, 1 joules per gram Celsius times 5 degrees Celsius. Your like units are going to cancel. So this Celsius will cancel this Celsius. This grams is going to cancel this grams. So now you're going to, now you plug it into your calculator. So you do 165 times 2.01 times 5 is going to give you 1,658.25 joules. In the PowerPoint, this is rounded to 160 or 1,660 joules, which is okay. Now we're done with that. We're going to do number 2. Number 2 is going to be our molar heat of fusion. So what you do here is you're going to take the information given to you and you're going to use your key to change it. So we are going to start with the molar mass that they give you. Okay, so 165 grams, and we're going to do our T chart. Oh, sorry, 165 grams. So we set it up. Here we're looking at water. So you need to put the molar mass of water down here. Molar mass of water is 18 grams, and that's going to give you 1 mole of H2O. Okay, that's going to cancel. Now you have moles of water, which is good because here in the molar or what is this? The specific heat, not specific heat, I'm losing it. In the molar heat of fusion and vaporization, it's telling you how much energy per mole is used, okay? So this is saying for your molar heat of fusion, 6.01 kilojoules for every 1 mole you have. So that's the conversion we're going to use. Since mole is up here, I'm so sorry about the printer. We're going to take a quick pause. So you have 1 mole, and we're going to use this to convert it into energy. Okay, so you're going to do 1 mole. 1 mole. That's going to give you 6.01 kilojoules, okay? Because that's what the formula tells you. Your moles are going to cancel, and you're left with kilojoules. But note that your problem wants your answer in joules, so you have to convert kilojoules to joules. So we got to do one more conversion. Remember, for every 1 kilojoule, you have 1,000 joules. This will cancel with this. So you're going to do 165 divided by 18 times 6.01 times 1,000. And that'll give you 55,091 point. We're going to round this to 67 kilojoules. I'm sorry, joules. Okay. Now you got to do number 3. So number 3 is going to be heat, very similar to the first one. So you're going to do Q equals MC delta T. M is going to be 165. Your specific heat for water, we already know what this is. This is going to be, since we're in joules, 4.18 joules per gram Celsius times your change in temperature. So here your temperature is 0. That's where your liquid starts, and then it's going to hit it up to this point, which is going to be 100 degrees Celsius. 0 is your initial, 100 is your final. 100 minus 0, this is going to be 100 degrees Celsius. And now we just solve it. Cancel, ooh, I always forget this grams. Cancel your like units and plug it into your calculator. So 165 times 4.18 times 100 is going to give you 68,970 joules. Okay. Now we have to do the molar heat of vaporization. So it's going to be the exact same thing as this one down here. So number 4, you are going to do 165 grams. Literally, it's going to be the exact same setup. 18 grams, 1 mole, 1 mole. Our conversion this time for vaporization is 40.7 kilojoules per mole. So this is 1 mole. This is going to be 40.7 kilojoules. We need it in joules. So 1 kilojoule is going to give us 1,000 joules. So you do 165. You're going to do 165 divided by 18 times 40.7 times 1,000. And that's going to give you the number that you need. So 165 divided by 18 times 40.7 times 1,000 is going to give you 373,083.3 joules. So 37,000, oh wait, no. 373,083. And now you gotta just do the final change in temperature. So the point it's getting it into a gas. So for 5, you're going to do the exact same formula. Q equals MC delta T. Your mass is still 165. Your specific heat is going to be, up here it's 2.02 joules per gram Celsius. And then your change in temperature is going to be 103 is your initial. And it tells you it wants it at 103. So up here is going to be 103 degrees Celsius. So you do 103 minus 100, and that will give you 3 degrees Celsius. Okay? Now plug that into your calculator. Your grams are going to cancel, your Celsius is going to cancel, so you do 165 times 2.02 times 3. That will give you 999.9. So now you take all of joules. You take all of the numbers that you got, and you're going to add them up for the total heat. So you do 1660 plus 55091.67 plus 68970 plus 373083.3 plus 999.9, and it gives you 499,804.87 joules. And that's how you do it.